first empirical, we've got a compound and it contains 40% carbon, 6.7 hydrogen, and 53.3% oxygen of mass. At this point, when you have percentages and they're going to equal 100%, just assume we've got 100 grams of the compound. So let's take a look at our carbon. So for carbon, we've got 40.0 grams. And we know in 1 mole of carbon has an atomic mass of 12.01 grams of carbon. And so we'll have 3.3 moles of carbon. 3.33 moles of carbon. Remember, just about anything you get into chemistry, dealing with stoichiometry, you got to find the moles. Let's look at hydrogen. So hydrogen, we've got 6.7 grams. And we're going to do the same thing here. I always like to put that over 1. And we'll call 1 mole of hydrogen is approximately 1.01 grams of hydrogen. Again, the grams cancel out, we're left with moles, and so that equals approximately 6.65 moles of hydrogen. Well, let's do the same thing for oxygen. So oxygen, we have 53.3 grams. So 53.3 grams of oxygen. And again, we have to put that over 1. And we know oxygen has a mass of 16.00 grams of oxygen in, oops, that should go down the bottom. Let me get rid of that. We know 1 mole of oxygen has a mass of 16.00 grams per mole. And so we can go ahead and do the math here, and we'll see that when we divide 53.3 divided by 16, we get 3.33 moles of oxygen. So what we want to do next is divide by the smallest number of moles. Well, I guess at either point here we can see that we've got 3.33 here, 3.33 there. So it doesn't matter which one we choose, those two are equal and they're the smallest. So 3.33 divided by 3.33, that will equal 1. 6.65 divided by 3.33, that's going to equal 2. And likewise, 3.33 divided by 3.33 equals 1. So this formula will have 1 mole of carbon, 2 moles of hydrogen, and 1 mole of oxygen. So our empirical formula for this particular compound will be C, which is going to be 1, H2, which you got to use a subscript, and 1 oxygen. So there's our empirical formula, CH2O. All right, let's look at problem number 2. So in problem number 2, we got a compound is composed of 27.3 grams of carbon, 72.7 grams of oxygen by mass. All right, so let's go ahead and find the mole ratio again. So for carbon, we have 27.3 grams. And we know 1 mole of carbon is 12.01 grams per mole. 12.01 grams. So we do the math here, and 27.3 divided by 12.01 is 2.27 moles. 2.27 moles of carbon. Let's go ahead and look at oxygen. Oxygen, we have 72.7 grams. And we know 1 mole of oxygen is going to be 16.00 grams. Go ahead and do the math here. And 72.7 divided by 16 is going to be 4.45 moles. 4.45 moles of oxygen. Again, we want to find the smallest number of moles, which is going to be 2.27. So if we divide that by itself, divided by 2.27, we see we have 1 mole of carbon. And we divide this one by 2.27. This will give us 2 moles. So for our formula, we've got 1 of carbon, and oxygen we have 2. So we use a subscript of 2. And that's actually carbon dioxide. So again, once you find a number of moles, take the lowest number of moles and divide each of the elements by the lowest number of moles and get the molar ratio. All right, let's look at a couple more. All right, for the molecular formula problems, we've got a compound has an empirical formula of CH2O and a molar mass of 180 grams per mole. So let's go ahead and calculate the empirical formula first. So carbon, we have 1 mole of carbon, and we know 1 mole of carbon is 12.01 grams per mole, and so 1 times 12.01 is going to be 12.01 grams per mole. All right, let's take a look at hydrogen. Hydrogen will work the same way. We've got 2 moles in the formula, H2, and we know hydrogen is 1.01, and so that's going to come out to be 2.02, and again that's going to be grams per mole. And likewise, let's do the same thing with oxygen. Oxygen, we have 1, and we know oxygen is 16.00. So that's going to come out to be 16.00 grams per mole. So we want to find the total here. So if we go ahead and find the total on this, 12 and 16 is going to be 28.01. So it looks like it's going to be 30 plus the 2.02. So we're going to end up with a total of 30.3 grams per mole. Well, from here, we know the molar mass is 180 grams. The empirical is 30.3. So what we want to do is find the ratio here. So let's go ahead and take 180 grams per mole, and we are going to divide that by 30.3 grams per mole, and that's going to give us approximately a number of 6. So we know our molecular ratio is 6 times the empirical ratio. So for carbon, we have 1. So So carbon's going to be 1 times 6, which is going to be 6. Hydrogen is going to be 2 times 6, which will be 12. And we'll look at oxygen. Oxygen will be 1 times 6, which is 6. So for this particular compound, we got 6 carbons, 12 hydrogens, and 6 oxygens. So there's our molecular formula right here. All right, let's take a look at one more. We got a compound, it has an empirical formula of Na2SO4 and a molar mass of 142 grams per mole. So we got to find the empirical formula first. So let's go ahead and find the empirical. So we've got sodium. We have 2, again from the formula. So we know it's going to be 2 times 22.99, and so that's going to equal 45.98 grams per mole of sodium. Sulfur, we've got 1, go to the formula, so 1 times 32.06. And again, you get these values off your periodic table. So that's going to be 32.06 grams per mole. And with oxygen, so we got sodium sulfate, so we got 4 oxygens, and we know oxygen is 16.00. So we've got 64.00 grams per mole. So we want to find the total mass. So if we add all these up, we're going to come out with 142.04 grams per mole. So lo and behold, if we look here, here's our empirical. So this is our empirical. And if we look up here, our molar mass is also 142 grams. So if we divide, again, the molecular, 142 grams per mole, divided by the empirical, 142.04 grams per mole, you can pretty readily see that this is going to come out to 1. So there's going to be no change in the formula. So the molecular formula is going to be Na2SO4, and that's what the empirical formula was also. So if we look at this, just another example of using empirical formula to find the molecular formula in another problem there. All right, until next time.